composite material for automotive and aerospace application. So application in aircraft and helicopter structures, aircraft brakes, aircraft seats, overhead baggage and components and compartments and the corporate fabric and space vehicles including UAVs, right, and satellite and multifunctional energy storage composites. I think we have gone through many aspects of an applications and most important today's scenario is a multifunctional energy storage composite material. So that's why I want to take it today's classes in respect of multifunctional energy storage composites. After that, we moving to that space vehicles including UAVs and satellites because these materials are mainly utilized in UAVs and satellites. So before you going to study the composite materials applications in UAVs and satellites, the multifunctional energy storage composite must be known thoroughly. So I'm moving to that concept of multifunctional energy storage composites. So what is actually multifunctional energy composites? So from this diagram you can able to know get some idea, I think so, right? What do you think about from this figure set? Can you guess some ideas, right? Yes. What do you have an idea from these figures? So this is a structure, an automotive car actually, automobile, and full of made up of and batteries. It means it's structurally generated by means of an battery system, which is called as an energy storage system. It can be used for making a structure also. So it generating energy at the same time it is going to be acted as a structural member. So it is a simply replica of the structural ability of a multifunctional composite material, how they are going to be utilized. And the introduction part about the multifunctional energy storage composites. So what is multifunctional energy storage composites? These are the materials that combine energy storage capabilities with the structural and other functional properties. Not only for an energy storage, it can also going to be used for other aspects like sensing and monitoring. So for sensing and monitoring also we need an energy. So energy going to be converted into one form to the another form with the help of a transducer. Then only we can able to sense and monitor the particular aspects. You know about the transducers. So what is transducer? The transducer converting one form of energy into another form of energy, but that energy can going to be an valuable one, that is a monitorable one. That's why the multifunctional energy storage composites are going to be used for an energy storage capabilities along with structural and functional properties. So they are designed to store energy, potentially serve as a structural component, and may even include a sensing and monitoring capabilities. Right. So this introduction to the brief idea about and what is multifunctional composites. Um, why we go for a multifunctional composites? So without composites, it's not going to be possible because and materials which are all an homogeneous in structure, like which have an alloy or it may be an metallic materials. It have only particular properties alone. It may be a thermally conductive material, it may be thermally non-conductive material, it may be electrically conductive, may not be conductive, and something it may be called as a shape memory thing or something. So these are single property aspects it have, but it doesn't have a multiple property aspects. So that the composite is going to be play a role for by combining the matrices with the regular materials of which are going to be acted as a catalyst or electrolytes. So that can be acted to creating some multifunctional properties. That's why the composites play a vital role in multifunctional energy storage material. And in the same aspect of introductory part, we have an idea about what is the need for an energy storage and lightweight application. You know that what is lightweight because the composites have a stiffness to weight ratios, so it produces lesser weight with higher stiffness ratio. So that it is called as a lightweight material. So need to reduce the demands of the system are told. The CP car in a 98% of energy associated with the weight, it can be reduced. Halving the weight, double the ranges. And similar to the adapting composites provide the weight saving, the electric vehicle with reasonable range and endurance. And the third one is structural power material. Undertake two roles, electrical energy storage as well as to carry the mechanical load. Imagine that it is Volvo electric vehicles. If these electric vehicles structure in itself made up of battery in nature, you know how much amount of energy going to be saved, because the most of the um, weight going to be carried by the payload apart from the payload of the passengers, the engine part, that is a vertical motors, and second aspect is most important thing is battery packages. The weight, the total weight of the system is going to be played by means of and the battery system. Imagine if the structure in itself acted as an energy storing or energy storing devices, or is converting the energy electrical energy in from any other aspects, then how much amount of um, weight going to be drastically reduced. That way the car body panel serves as a battery, so all the panels like which are all exposed to the various environment, and some other structures are going to be creating the structural ability, and remaining parts which are all going to be cover the surfaces only going to be taken as a part. So that way it will reduce a more amount of weight reduction, especially in an automotive industries. And the another aspects in multifunctional structure, structural and non-structural, it means energy storage capacity. This one is a part, a distinct constitution components packaged together. So the carbon epoxy is a packaging here, and PL that may be polylactic or something. It can act as an energy storage, and carbon epoxy packing resin is a structural ability. You know, carbon composites are more structurally able material for an automotive and aircraft application. And in between, only for the surfaces is good enough for the structural ability, and remaining portions which are all creating energy storing ability. So that's a the multifunctional design aspect for this going to be used. This simple example will show that it is a rotating member and it is a panel. The panel going to be acted as an energy device, then it's going to be run the propeller. Then it is easy to run, acted as in structural as well as the energy device like a battery. And similar way, the some other method, we are going to be generate an multifunctional material and constitution simultaneously and synthetically undertake the two roles. One is a matrix part, and which can be separated by the glass fiber acted as an insulator, and one may be acted as a cathode, and the another one may acted as a anode. So the carbon fabric is acted as a anode, and in between we have a metal mesh. It is going to be acted as a cathode. So this will called as an electrolytic member. So creating electrical energy during the charging method. The charging may be done by means of any aspect. It may be solar powered or wind powered or something. So a conventional energy system is going to be used to generate an electrical energy storage inside the surfaces. So that acted as a member for structural ability. Because of this, the glass fiber, which will creating the more amount of mechanical properties, and other things can be useful for generating the electrical energy, right? So that way we are going to be generate a multifunctional material design. So this is the most important one. Wetzel and Snyder, who are all US Army Research Lab, working in the US Army Research Lab for generating a multifunctional. He is demonstrating something called as a zero energy field. It means if you are using the structural plus energy generation, if both of them equal in nature, then one is going to be acted as a structural member, another going to be generating energy. With the zero potential energy, we can able to convert into one form to another form, or we can able to generate then mechanical energy with the help of zero energy potential. So structural energy storage was first investigated under the auspices of DRDA, that is called Defense Advanced Research Project Agency, a synthetic multifunctional material program in the early 2000s they are generating. In all the cases, weight saving or increasing the weight specific energy are in the main place. Weight saving is a main way, or increase the weight specific energy. How much amount of weight we are using, that is equal amount of energy going to be generated. If you imagine that we are using a lithium battery that have enormous amount of weight, then equivalent amount of potential of generating electrical energy is going to be played. If in vice versa, if you are reducing that weight but increasing the energy, you know how much amount of efficiency of the system going to be improved. So Wetzel demonstrate the possible weight benefit by using an explanatory ground vehicles. Let's say introduce the structural mass efficiency, that is sigma s, to represent the structural property such as stiffness to weight base, stiffness to the strength, and relative to the conventional solely load carrying composite structure, that is sigma s equal to 1. If it is conventionally only carrying the structural member, then sigma s, sigma structure, it means it will indicate the strength. Sigma is indicating the strength. The strength related to the structure is equal to 1. Analogously, an energy mass efficiency measures sigma E, that is, if it is only producing the energy like a battery, then it is called as sigma E equal to 1. But the weight not going to be creating a structural ability, then sigma S at that condition is 0. So accordingly, regarding to the conventional system, which is strict functional separation, sigma S battery equal to sigma E structure is equal to 0. It means not, it is only for the functional ability. It is not producing energy as well as not making a structural ability also. Then according to Western, the total system mass M total is going to be considered in dependence of both efficiency factor and masses of the original structure. It means M structure and M battery. So in that case, if M structure is equal to actually M total plus 1 minus sigma is the battery multiplication with M battery divided by sigma equal to battery. So if you imagine when the M total value is going to be 0, then sigma S battery and sigma E battery is going to be high. So if it is equal to 1, it will become 0. Then M total equal to M structure. So sigma S battery equal to, if it is a structural ability, it have 1. If it is an energy storage, it is equal to 1. So that's why you know how amount of M total going to be changed with respect to the multifunctional material if you are generating. So this is actually called as Wetzel demonstration about the efficiency of the system with respect of an weight to the specific energy. So that will produce that weight to the specific energy. How much amount of specific energy you can able to generate with the help of the amount of mass you have, right? And how you are going to be get an idea about that. The concept of multifunctional energy storage cross-play composite is functionalized constitution. And second one is calculated the system mass reduction according to the weight. So here imagine one is a energy storing, another one is a polymer composite for the structural properties. When you are combining these two, you are going to be generate that multifunctionalism, all solid state energy storing composites. Here you can know that sigma E equal to battery, it means it's equal to 1. When sigma E equal to battery for 0.75, it means the remaining is sigma structural. So sigma E equal to battery is 0.5. So that way the structural energy and for M battery is 1500 kilogram. For structure we are using 1000 kilogram of mass, and for the generation of electrical energy we are going to be generating 500 kilogram mass is required. Combining together it is 1500 kilogram. But in a conventional system we need more total of 1500 kilogram of system for your creating the energy. In aspect of sigma E equal to battery or sigma E equal to only for structural, then it is going to be highest 1500. In case if you are using 0.5, it means the remaining is structural and remaining is taken as an energetical one. So the reduction in the mass is going to be high. So normally system mass is in minus sign. So the amount of reduction in the mass is increasing the structural mass efficiency going to be high. So that will that is the property of a multifunctional energy storing cross-play laminate. Okay. So these are simple example for you, and it is overall be about that what is a battery, what is the structure, and what is the combination of these two. So sigma S is a structural energy. You know that when sigma S equal to 1, then only we are generating 750 kg of structure. And second one is sigma E equal to 1. So only we are generating the battery. The battery is inbuilt to here, and Tesla car is going to be generated by help of 1230 kilograms of total mass. So just for a symbolic representation with respect to one, the elements is what we are using as sigma S, and then for sigma E. Sigma S equal to 1 and sigma E equal to 1. It is indicating only it is an energy device, only it is 1 also. So sigma equal to 0.5 and sigma equal to 0.8 and sigma s equal to 0.7 and sigma s equal to 0.8. And these are the three representation with respect to the system mass to the structural efficiency, and mass going to be drastically reduced with the help of an increase in the multifunctional ability. And this indicating only for the structural because it's an energy, so it is for battery. Only for generating the energy, there is no amount of mass reductions. So rule of thumb is actually sigma s E plus sigma s should be greater than 1. So that type of structural power material is going to be useful for the particular application. Right. And what is our vision and ambition for multifunctional structure? So these are in previous line we have an idea about the introduction part of a multifunctional composite structure. Now, what is the aim of our for generating multifunctional composites? So one and foremost, first and foremost is actually lightweight. It will, by means of lightweight, we are improving the energy efficiency. And second one is the multifunctional. So we are going to reduce the mass as well as the volume. And third one is a strong. It carries the mechanical load as well as the electrical load. And fourth one is efficiency. It means provide the energy storage. With the help of that, more amount of energy going to be stored in the enormous directions. So driven by a novel material design for the future, then only we can judge it lead towards the energy efficiency, environmental friendly and materials. So where it is applied? It is applied in hybrid electrical vehicle, or in aerospace and military application and portable electronics and oil and gases. So in military as well as the aerospace, so no need of an energy device like a fuel to be filled in that particular aircraft or something. It can in itself generating more amount of energy and then moving towards the directions. So the hybrid electrical vehicles and oil and gas industry and portable electronic devices, military applications are in many much more applications being there in multifunctional structural power composites. And interdisciplinary material research. The main focus is on interdisciplinary material research. One is structural power materials. New and technological changes is really required. Potentially huge saving and diverse range of applications. And interdisciplinary skills required. Electrochemistry, polymer chemistry, mechanical engineering, material science, physics and chemical engineering. So only one field, like you know that mechatronics. So in earlier 10 years before or 20 years before, the mechanical including the automations, then we go for the requirements of electronics people. Instead of getting that consent from them, why the mechanical engineer in itself they are going to be studied in electronics subjects. That way the mechatronic systems are generated. And similar way nowadays, so all these field of study is going to be implemented, then the newer field is going to be developed like that. So electrochemical energies and polymer chemistry, mechanical engineering, material science aspects, physical and chemical. That's why the multifunctional material research can be able to generate the more amount of potential research focuses on the combination of an interdisciplinary research aspects. And spectrum of material it may be mechanically dominated. It means the bike frame and covering which are all going to be implemented by means of GPS. Okay, global positioning system. And electrically dominated. Example, shell of radio controlled in the aircraft. The smallest shell of radio can be controlled the aircraft. So these are some of the applications we have. And first structural battery we are generating. And second thing is the overall structure in itself is generating the energy. Solar power generated energy or some other type of energy is going to be happening. So this is an interdisciplinary material application of interdisciplinary material research. And you know that the fuel cell is one of the most important aspects of generating electrical energy and structural ability. It's one of the best example for a multifunctional material. So it is simply a material, but it's acted as an energy device, right? So it have various combination of structures. This is actually a propagated skin and the outer skin, and this is actually sealing methods and which are to acted as a anode, and another one is going to be acted as a cathode. This fuel cell, but main drawback in the fuel cell is the weight of the fuel cell is so high because of the complicated structural ability. So it can able to withstand more amount of load at the same time it acted as an energy devices. That's why it's the first and foremost device in multifunctional aspects, right? And for the another aspect for structural super capacitors. So this is structural super capacitors which is used for an advanced vehicle system. And lithium ion structural battery, which is a structural very thin structures can be acted as an energy device. So it can be implemented in the various structures for producing the acted as a energy devices. So all the structures, if the lithium ion structural is coated, then the structure in itself acted as a energy device. So we can able to get the more amount of energy from the structure itself. So this is another multifunctional material application. We can easily generate it by means of simply applying that lithium ion structure on the surfaces. It can able to produce an energy device. Then for making a carbon fiber composite in the batteries. So carbon fiber is its highest amount of strength. At the same time, it is going to be acted as an um, cathode or anode. Like so, lithium ion intercalation or carbon fiber battery electrodes are going to be take, and in itself, the structure itself can able to absorb the energy and store the energy. Right? So this and lithium batteries and carbon fiber impregnated with that, and between the cells it is going to play a role for an electrolyte, and it will absorb the energy. So this is an application for the specific strength of various materials. So initially we are using a steel nowadays and moving towards the titanium alloy for high strength, and for glass fiber thermoset polymers, and then nowadays we are using for carbon fiber and thermoset unidirectional polymers with highest amount of mechanical strength. Along with that, multifunctionality is going to be there. So this graphical representation indicate about how we are improving towards the direction of and multifunctionality with the help of a known value of strength ability, right? Okay. And the capacity of band-passed carbon fibers. It means it acted as a cathode and anode for capacity building for generating more amount of electrical energy. So electrode potentials are decreased with respect to what increasing that delethalization. So if you are improving the lethalization, then it's going to be higher. But the main drawback is we need to be get and crosswise, that is an optimized level of lethalization. Then only it have both um, mechanical as well as the electrical energy properties. So this is for impact of electrochemical cycling on the tensile properties of carbon fiber. And one another study is also being there, which which will be creating um, um, optimality between the structural ability of the member to that energy storing capacity of the structure. So that should be optimized, and we need to be get thoroughly about how much amount of mechanical energy can able to withstand. At the same time, if the mechanical forces are applied, it's going to be changes in the deformity. Because of this deformation, the electrical energy should not be get affected. So then both the directions we need to be go for that. If you are introducing and the required amount of electrical property, how deteriorate the mechanical property. If the mechanical application is being there, because of those that there may be the deformation. The deformation curve is going to be affect the electrical energy. So in both the directions, the research oriented aspects could be very much required for that. So still we are in the focus of identifying the multifunctional material, especially in our applications. So the people are still going to be searching on that the combination of various materials, right? This is for structure of electrical ability with increasing the stiffness. You know that with increasing the stiffness, the conductivity of the material going to be reduced. It means increasing the stiffness means it will have the highest amount of structural ability and lowest amount of electrical energy. In case of our polymer matrix composite, so the optimized level of stiffness along with and electrical energy must be required. So it is a mechanical enhancement with a diffusion enhancement. It means the cross-linked methyl chrylates and lithium salt dissolved in the monomer mixture prior to the group, and lithium ions can coordinate the oxygen in the ethylene oxide to act as an electrical device or electrical storage for absorbing the electrical energy during the charging as well as going to be discharged in the electrical energy. Okay. And it is that giving the relationship between that the polymerization process along with that conductivity of the material. So with increasing that, it is the conductivity is going to be increased with the help of cross-linking monomer, and this is actually sorry, conductivity is going to be drastically reduced, and the another aspect is going to be increased with increasing that electrical energy. One is actually stiffness ratio, and another one is actually called as electrical ratio. In terms of logarithmic scale which is going to be taken, because of those we can able to take the x-axis as a common one, because these values are in different aspects, so we are going to be take it as a logarithmic value for identifying the conductivity and crosslink enhancement. So one is actually mechanical enhancement, another one is called as a electrical energy storage ability. So ionic conductivity versus modulus with respect of cross-linking monomer simulation. So always we are going to be check with the microstructural ability of multifunctional materials. So the high polymer mobility improves the ion transplant but reduces the mechanical performance. So nanostructure to ensure the structural robustness while allowing ion migration also. So the nanomaterials, the implementation of nanomaterial is going to be play a vital role for multifunctional material aspects. So this is a simple device architecture, but the thickness of this is in the form of in micron. So it's a structural battery. Already we have seen the last one. So how it is being structured like that? So it is a multifunctional material. One is a multifunctional polymer matrix and copper foil on the end for the connectivity, and cathode is one. Another one is the anode. And remaining carbon fibers it acted as a anode for gate, and which will going to be carded as a separator. It's an insulator also. And some of the technical and non-technical needs, but they also have some challenges. That is all called as bottlenecks. One is a power density and fundamental issues. And moderate electrode conductivity, robust matrix inhibiting ion migration also. And matrix dominated mechanical properties dictated by delamination and compression. These are the mechanical properties going to be deteriorated. So delamination is going to be takes place while because of an non-combination of materials, which will creating that particular properties actually. And additional electrical functionality because of variable materials imperfections, and completing the demands on fiber and matrix interface. Cast and fabrication, it means principal hurdle for the polymer composite fabrication. And structural power materials, it means make it moisture free environment. Hello.
भाई मैं पापा को क्या बोलूं कि पापा ऐसा मैं आरुष एक 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 झांट सा ऑर्गेनाइजेशन झांट से कंपटीशन.
Okay. So non-assembled to finishing process, cutting and drilling. Some more time, we want to make it as a structural member. We need to make a drill or any of the particular shape. So that will change the material properties. It may continue same electrical property. It may generating some electrical discontinuity also. So imagine I am making a composite like the earlier one, which may be called as an uh, lithium ion battery using the composite material. But because of making a drill or something, it may reduce that properties. So when we make some drills on this purpose, it will creating some electrical discontinuity. Okay. So this is some of the issues related to that, durability, repair, lifting, recycling, safety. These are the another environmental effect of generating multifunctionality material. So that for specific application where it is really required for those, and but for those applications we are going to generate and multifunctionality ability. So we want to show that electrical connection, lightning strike production, energy harvesting, or another aspect. These are some of the opportunities for common themes. So distributed energy storage for safer road vehicles, highly diverse range of potential applications as performance is going to be increased. It has a sparked interest from other sectors and fertile ground for development of new technologies, novel material architectures, solution for conventional composite and electrical conductivity. So it is a lightning strike. So we studied one of the property which is going to be lightning, avoid the lightning effect, especially in aerospace industries, right? Right. This is actually structurally power materials. Most amount of energy going to be generated with a specific weightage. So that's all about. And these are some of the applications for component design and implementation. So